Hey guys, so I chose to present today on water lilies because I feel like we talk a lot about regular terrestrial plants in class, which makes sense because of their abundance and importance to research, but there's also aquatic plants, and I was just curious about what kind of adaptations aquatic plants might have that make them different from terrestrial plants we've learned about. Of all the aquatic plants I could think of to look at closely, I chose the water lily because it's one I've actually seen and interacted with in real life. Anytime I see them, I'm captivated by their appearance floating on top of water, and I'm impressed by the amount of wildlife that always seems to accompany them. So, water lilies are of the Nymphaceae family. They are perennial, mostly herbaceous angiosperms, which means they're flowering plants. Water lilies are found in temperate and tropical parts of the world in freshwater habitats. They prefer relatively still or very slow moving water that is slightly acidic. From an evolutionary perspective, they are thought to be an important transitionary species because for about 225 million years, all seed plants were woody. But when angiosperms came onto the scene about 140 million years ago, fossil records and phylogenomic evidence show that they became one of the first seed plant lineages to become herbaceous. An important feature about water lilies is that they have a complete loss of their vascular cambium, so they don't have a xylem or phloem, which, as indicated in class, is because their stems already have plenty of access to water and nutrients. Because, like most plants, they still need to photosynthesize, so their leaves need to have access to sunlight. Water lilies have leaves that tend to be circular and can range in size depending on species to species. Here's what a typical water lily leaf looks like, and here is a leaf from a giant lily found in the Amazon. Water lily leaves also have a waxy cuticle on top of their leaves. This helps with buoyancy by repelling water so that it doesn't collect on top of the leaf, weighing it down and causing it to sink. So something unique about their leaves that is opposite in most plants is that their stomata are found on top of their leaves. This is because stomata, as we know, are important structures for gas exchange from the plant and the atmosphere. If the stomata were on the bottom of the leaf, where it meets the water, releasing oxygen and uptaking carbon dioxide would be a lot more difficult and inefficient. Gas exchange within the plant is carried out by a tissue called aerenchyma. Aerenchyma is a soft spongy tissue filled with air pockets. These air pockets are also important to help the stem and leaves stay buoyant in water. Something interesting I found while researching water lilies is that they have circadian rhythms, similar to the squash and zucchini that I've had my own experiences with. Water lilies flowers open in the morning and close in the afternoon. This is because this time of day is when the flower has its best chance of being pollinated, while it's still relatively cool outside and pollinators are active. This adaptation helps preserve the flowers so that they have many days to allure pollinators before the flowers are spent. So I talked earlier about how wildlife always seems to accompany water lilies wherever they may be, and this is probably my favorite thing about them besides their flowers. Water lilies provide great homes to many organisms because they're herbaceous and they provide cover. This allows herbivorous creatures to feed on them as well as provide safety for fish and other organisms from birds and other creatures. We've all probably seen the stereotypical image of a frog sitting on a lily pad, and for good reason. Frogs, turtles, dragonflies, damselflies, snails, beetles, and other insects can often be found where you find lily pads. One last important role of lily pads in their habitats is that their shade keeps the water beneath them relatively cool and limits the amount of sunlight that can penetrate. This helps keep algae populations in check, thus preventing eutrophication, which can make water anoxic, suffocating the other organisms that live in the water. Alright, so with that, I'll conclude this talk, and thank you for listening.